The interaction picture Hamiltonian is a way where we have to find out the total energy of a system. So this interaction picture Hamiltonian plays a very crucial roles in atomic system when a field is interacting with an atom. So how to derive this interaction picture Hamiltonian, and let I would like to start this from a very simple equation. We can represent this by nu t. You can also represent this by ht, it's no problem. This is just a symbol. And u naught dagger, this is the unitary operator, and hi, the interaction Hamiltonian, and u naught t. This is the basic equation. We can derive the interaction picture Hamiltonian, where we know about u naught t. U naught t as the unitary operator. This is a dagger on this u naught t. Then we can say that u naught t, which is equal to e to the power minus iota h naught t divided by h cut. This is the value of unitary operator, and by taking the Hermitian conjugate or dagger, we can write this minus iota h naught t divided by h cut, and this must be positive because this is a dagger, so this is minus, this will be plus. And hi, we know about hi, the interaction Hamiltonian, and for a two-level system, minus h cut omega r and e to the power minus iota phi a b plus e to the power iota phi b a. So this is the interaction Hamiltonian, and omega r, we know this is the Rabi frequency, and u naught e to the power minus iota h naught t divided by h cut. This equation is equation number 1. Here this equation is nu of t, which is equal to e to the power iota h naught t divided by h cut. This is the hi. Here we have cosine nu t with multiplication. So this is the Hamiltonian. This is the interaction Hamiltonian of a two-level system when a field of nu is interacting with this. Now I would like to consider this term and want to calculate this term and this term, and putting the value of this and this in this equation number 1, and finally we will find the interaction picture Hamiltonian. Let's consider this term e to the power iota h naught t divided by h cut, and we know that e to the power x, which is equal to 1 plus x square divided by 2 pictorial, x3 divided by 3 pictorial, and so on. So this is just, we can expand the exponential, and 1 plus iota h naught t divided by h cut plus iota h naught t whole square divided by h cut square. We can take this whole square divided by 2 pictorial, and so on. Further, h naught, the value of h naught, this is equal to iota divided by h cut, and the value of h naught for a two-level system, h naught is equal to h cut omega a plus h cut omega b b b, and from here we know iota square divided by 2 pectorial means 2, and h cut square and also t square and h naught square means multiplication of this with this term whole square. Then we can say that h cut omega a plus h cut omega b b b with multiplication of this h cut omega a plus h cut omega b b b. And next, the higher terms. Now 1 plus iota divided by h cut and h cut omega a, we can multiply this term iota h cut, then iota h cut will be cancelled out, and we must have a iota h cut omega a multiply this with this, h will be cancelled out, iota omega b b b, and we also have a t here, so a t here and t here. Then further, iota square t square divided by 2h cut square, and there is a multiplication, this multiply with this. If this term is multiplied with this, then a this will be equal to 1, and h cut square omega a square, and we have a and a. And if we multiply this with this term, so this a and b, this is orthogonal state, this will be equal to 0. And then this with this, because BA, this will be equal to 0. And if we multiply this term with this term, then we can get h cut square omega b square BB, and so on. Now we have AA state here, and third term and fourth term and so on. BB state here, BB state here, and third term and fourth term. So I would like to separate the A state and B state. Then 1 plus iota h cut omega a t plus here iota square t square divided by 2h cut square, and here if I multiply this with this term, then h cut square and h cut square will cancel out, and we have omega a square and a, and plus the third term, fourth term, and so on. And similarly, if I take iota plus omega b b t, and this term is plus iota square t square divided by 2, and omega b square b b, and plus third term, fourth term, and so on. Now, what will happen? I think there is no h cut here. There is no h cut here. There is no h cut here. because h cut and h cut is cancel out. Now the next point is I am interested to write the A state common. This, if I take A common from here, then 1 plus iota omega A state common, and T plus iota square T square divided by 2 pictorial omega A square plus similarly the third terms and so on. And if I want to take A state from this plus similarly I can take common B state, BB state, iota omega BT and plus iota square T square divided by 2 pictorial omega B square and the next terms and BB. Here this term and this term to find to write this in an exponential form. But the problem is an exponential, if we have an exponential 1 plus x square divided by 2 pictorial and so on, this is equal to e to the power x. And similarly, if I look this term, then if I add 1 plus this, then I can write, if I write this 1 plus iota omega at plus iota square t square divided by 2 pictorial omega a square and so on, then I can take this e to the power iota omega at. This is possible. But the problem is there must be one here, 1 plus this thing. But this one is outside because we have taken a as a common from this, and similarly we can have this state. So we must add 1 here and 1 here. Then how this is possible? So this is the point that we should looking for this critical point. So how this is possible? The only possibility is if we write this one in a completeness relation, AA plus BB, which is equal to 1. If I replace 1 by this here, then it has some possibility because AA plus BB, this is 1 plus the remaining terms iota omega at plus iota square t square divided by 2 pictorial omega a square and AA plus iota omega bt plus iota square t square divided by 2 pictorial omega a square plus and BB. Now one thing is clear, if we now this and this, we can take common from this AA state, take common from AA, then we have 1 plus iota omega at plus iota square t square 2 pictorial omega a square and AA common. And similarly, this and this we can take common B state, then we can get 1 here, and iota omega bt plus iota square t square omega b square. This is omega b square divided by 2 pictorial and bb. Now it's simple because this term, this is the exponential term, and this is equal to iota e to the power iota omega at. This is the exponential of this, and aa plus this is the exponential of iota omega bt and bb. So finally, we derived this e to the power the exponential term, and here e to the power iota h naught t divided by h cut here. And similarly, there are only minus here, then we must, if we, in a similar way, if we calculate and expand e to the power minus iota h naught t, then this must have minus iota h naught t divided by h cut. This must have e to the power minus iota omega at aa plus e to the power minus iota omega bt and bb. So we will follow equation 1, putting the value of this exponential and this exponential. So it means equation 1 implies means we can put the value of exponential this. So the value of this is e to the power iota omega at aa plus e to the power iota omega bt bb, and this term already we know, minus h cut omega r and e to the power minus iota phi ab plus e to the power iota phi ba and cosine of nu t. And also with multiplication, this is a multiplication with this. So this term e to the power minus iota omega at aa plus e to the power minus iota omega bt. Now first of all, multiply this term with this. If I multiply this term with this, we must have minus h cut omega r. We can take this common. This term with this. So a multiply with a, then this becomes 1, and we have e to the power iota omega at and e to the power minus iota phi, and we have remaining a and b. And then multiply this with this term. Then this a is multiplied with b, then this is orthogonal state and this will goes to 0. Further, multiply this with this, so ba, this is orthogonal state which is equal to 0, b into this, then we have e to the power iota omega bt, e to the power iota phi and ba, and this term remains in a multiplication, e to the power minus iota omega at aa plus e to the power minus iota omega bt and bb. Further, multiplication of this term with this term minus h cut omega r Multiply this term with this term. So here b and a, this will be equal to 0. And multiply this term with this term. So b, this will be equal to 1, and we have ab, e की power iota omega at, e की power minus iota phi, and e की power minus iota omega bt. One thing we have missing here, and this is cosine of nu t, because cosine of nu t is here. So this will be in multiplication. And we have a b. And then multiply this term with this term. Then a1. Then we have iota omega bt e to power iota phi e to power minus iota omega at and ba. And cosine of nu t. Nu t, which is equal to minus omega r. Add the exponential this one and this one. Then we have iota e to power iota omega a minus omega bt and e to power minus iota phi a b plus e to power minus iota omega a minus omega b into t and e to power iota phi ba and cosine of nu t. What is this? This is the transition frequency nu t, which is equal to minus h cut omega r and e to power iota omega abt. This is the transition frequency, and e to power minus iota phi aa ab plus e to power minus iota omega ab into t and ba. And cosine theta, we can write this iota nu t plus e to power minus iota nu t divided by 2. Further, nu t, this is a simple calculation now. We must multiply this with this, this with this. So e to power iota omega a b plus nu t f and ab, and if we multiply this with this, so e to power iota omega ab minus nu into t and ab, and then multiply this term with this term, then we must have minus iota omega ab minus nu t ba plus e to power minus iota omega ab plus nu t and ba. Last time I discussed about transition frequency plus field frequency, and these two are in the order of 10 to the power 15 hertz. So this term is very highly oscillating term, and due to rotating wave approximation, we must ignore this term and this term, and we ignore this term. And finally, we have minus h cut omega r divided by 2 and e to power iota omega ab minus nu t ab plus e to power minus iota omega ab minus nu t ba. And omega AB minus the difference between two frequencies is known as detuning. So we have the detuning delta here, and iota delta t. We have messed one thing as e to power minus iota here, e to power minus iota phi here, e to power minus iota phi here, e to power minus plus iota phi here, and here is e to power iota phi. So please add this term, e to power minus iota phi here, and here e to power iota phi, and e to power minus iota phi and a b plus e to power iota phi, e to power minus iota delta t, and ba. So this is a very simple Hamiltonian for a two-level system. Now it's how to write directly for different system the interaction picture Hamiltonian. Let's see. Suppose we have a two-level system, and this two-level system is interacting with a field has frequency nu. Then if there is an electron here, this electron is continuously oscillating due to this field, and this has some frequency omega. Let's see, this is omega r. Then directly how to write the Hamiltonian for this system, the interaction picture Hamiltonian. The interaction picture Hamiltonian, we can represent this by ht, no problem, nu t, it's okay. Here, minus h cut divided by 2, this is important, minus h cut divided by 2. And then here the Rabi frequency is omega r here, and this field has some phase, then I can write down this. And if there is some detuning, for example delta is the detuning, then we must write iota delta t here, and this is a and b, and then conjugate of this. If I write the conjugate of this as omega r star and e to power iota phi and e to power minus iota delta t, and this is ba. And now if I consider that this omega r, this is a real number, then we can say that omega r, which is equal to omega r star, then we can take this common. Then ht minus h cut omega r divided by 2 e to power minus iota phi e to power iota delta t ab plus e to power iota phi e to power minus iota delta t and ba. So this is remains the same for this. We have some another system, and this is 1, this is 2, and this is 3. And here a field is interacting with this field having frequency nu1, and this is oscillating between these two levels 1 and 3 with Rabi frequency omega 1, and here it has some detuning delta 1. And from this side we have another field which has frequency nu2, and this is interacting between level 1 and 2. Then this as the electron will oscillate between 1 and 2 with some Rabi frequency, let's say omega 2, and this has some detuning delta 2. So what will be the interaction picture Hamiltonian for this system? And this is very, very easy because we know h minus h cut divided by 2. This is important for every Hamiltonian, for every system. And now look the levels that the field is interacting. 1 and 3, the field is interacting this omega 1 is some Rabi frequency. And this field has some phase like minus iota phi 1. And it has some detuning, then iota delta 1t and a 1, 3, 1 and 3. And then the other field, nu 2, which is interacting between 1 and 2, then we must have Rabi frequency omega 2. This must have some phase minus iota phi 2 and some detuning iota delta 2t and 1, 2. And then conjugate of this and conjugate of this. So conjugate of this is equal to omega 1. It is, if it is real, then we can say that's omega 1 and e to power iota phi 1 e to power minus iota delta 1t. This is 3, 1 plus omega 2 and e to power iota phi 2 e to power minus iota delta 2t, and this is 2, 1. So now this is very easy to write the Hamiltonian for a very complicated system as well. Now consider a 4-level atomic system. And here in a 4-level atomic system, a field from this side is interacting with this A and D, and it has some frequency nu 1. Then it can oscillate the system and AD with some Rabi frequency omega 1, and here there is some detuning delta 1, and here from to A and C there is some another field which is interacting with A and C, and this is oscillating with Rabi frequency omega 2, and a third field is interacting with BC, and it is now have Rabi frequency omega 3 and some detuning delta 3. So what will be the interaction picture Hamiltonian for this system? Starting from this H, which is equal to minus h cut divided by 2 omega 1 with some phase minus iota phi 1 and e to power iota delta 1t. This is the detuning, and A and D. This field is interacting with A and C. So omega 2 e to power minus iota phi 2. But here there is no any detuning. This is completely resonant. This field is resonant with this transition frequency. So at resonant, if we have the delta 2 here, then delta 2 is equal to 0, then the exponential term will be equal to 1, because e to power 0 means delta 2 is equal to 0 means it is equal to 1. So there is no need to write the exponential term because it goes to 0. And AD, AC. And the third field is omega 3, and it has some detuning delta 3 e to power minus iota phi 3 and e to power iota delta 3t and BC, and the complex conjugate of this and this.